Hello everyone, my name is Imran Aftab and today we are going to learn about microcontrollers. So before going on microcontroller, first of all we try to know that what is microprocessor. So a microprocessor is a computer's processor which incorporates the function of a computer's central processing unit on a single integrated circuit. So it's a simple IC, but it's a programmable one. Then why we are going to learn about microcontroller, not microprocessor? Because microprocessor is little expensive. Because maybe because you know that if you buy a laptop or computer, then it costs you around 50,000, 40,000, 60,000, like that. But a microcontroller is much cheaper than this one. So if you want to make a small device like a security system or you can say a small robot, then you can't expend that much of money on a small device. So for the small device, generally we use microcontrollers. So a microcontroller is a small computer on a single integrated circuit. So it's a small computer on a single IC, on a single IC. That's why it is known as a system on chip, or in short we can say SoC. A microcontroller contains one or more CPUs along with memory and programmable input-output peripherals. Program memory in the form of ferroelectric RAM, NOR, flash, ROM also often included on a chip as well as a small amount of RAM. That means it is having everything what a computer or a CPU needs for running a computer. That means ROM, RAM, everything it is having embedded inside a small chip. That's why it is known as SoC, system on chip. So there are various microcontroller in the market. There are various manufacturer manufacturing different type of microcontrollers. So it depends on you that which microcontroller you want to use, and it depends on the product, what type of the project you want to develop. So uh, you for different project you may need to use different controller. So before going to learn various microcontroller, you need to concentrate on a single microcontroller. If you can use a if you can use a one microcontroller, if you are having a good command on a one microcontroller, then you can easily switch on different microcontrollers. So here we have chosen AVR microcontroller. It's a very famous microcontroller for learning purpose or even for different projects you can use it. So you can go for any microcontroller. Okay, but you need to start with one microcontroller. So we just for learning purpose we have started with the AVR. So here AVR stand for Advanced Virtual Risk. Advanced Virtual Risk. This one. Okay. So an advanced virtual risk, and it is a 8-bit microcontroller. That means its processing CPU can process 8 bit of data at a time. 8 bit of data at a time. And as we have discussed already, that it's a microcontroller, so it is having flash, RAM, ROM, EEPROM, input, output, everything is embedded inside the microcontroller. So here is a AVR architecture. Although the architecture is of a microcontroller is very complicated, but we are going to just understand the architecture with the help of block diagram. So as we know, there are two types of devices are there, like input devices and output devices. Input devices like our monitor, we can say LEDs, motors. These are output devices, and input devices like keyboard, you can say mouse. You can say like if we discuss about embedded devices, then we can take an example of switches, sensors. These are input devices. So here, for controlling those input output devices, we are having input output register, or we can say input output ports. We will discuss about this input output in detail in the next slides. Then after, we are having ADC block. As we know, in our real life, generally signals are in analog system, not in digital. But our microcontroller is a digital device. So for converting analog to digital, we are having this block ADC. ADC stand for analog to digital converter. And if you want to communicate two devices, okay, suppose if you want to control your device or project by your mobile phone, that means you are communicating between, you are making the communication between two devices, your mobile phone and your device, whatever you have made by with the help of microcontroller. So just like if we are communicating, then we are following some type of protocol, like we are just we are understanding English language. So we are following some sort of rules of English language. So that's how you are understanding my feelings, and even I can understand your feelings. Okay, so here we need to follow some protocol so that our machine can understand each other. So here is a very simple protocol by which we can make the communication between two devices, and that is known as USART. USART. It's a short form. In its full form is Universal Synchronous Asynchronous Receiver Transmitter. We will discuss uh, in detail about these peripherals in detail in next videos. And we are having timers is generally used for calculating times or making delays, maybe you have heard about ultrasonic sensor, or you can say a radar. Then in that case, we need to calculate the time, that how much time taken to send the signal and to receive it back. So in that case, we need to calculate the time. So in that case, we can use timers. And in the middle, we are having CPU, Central Processing Unit, and for storing the program or data, we are having a memory like RAM, ROM, EEPROM, and for running every device, we need power supply. So here externally we need to give power supply. Then after, we are not going to discuss much about the history of our microcontroller. Actually, it was developed in the 1996 by Atmel Corporation. Atmel Corporation is the manufacturer name. AVR category. There are various microcontroller which comes under the AVR. So all microcontrollers are categorized in three types. AVR microcontroller is divided into three types. So first is teeny AVR, second mega AVR, third one is X mega AVR. So suppose if you want to make a very small device, like I can give you an example, like if you want to make a small alarm system, then you need a very small amount of memory, very less number of pins for controlling that alarm system. So in that case we can go with the tiny EVR, in which it is having very less amount of memory, very less amount of pins. And if you want to make a average size of or average feature of project, then you can go with the mega AVR. It is having uh, it is having a good amount of memory, up to 256 KB, higher number of inbuilt peripherals, and suitable for moderate to complex application. So here we will use mega AVR. Mega AVR. We are not going to use teeny AVR, and we are not going to even use X mega AVR. Here we will use mega AVR. The programming is same for everything. Only you need to know the pin diagram, pin description about different microcontroller, and you can easily use. So here we will focus on mega AVR, and X mega is commonly for the complex application which requires large program memory and high speed. Generally, it is used in the industries. And mega AVR generally used for the moderate type of application, or you can say, even we can say it is generally used for the study purpose. Then after, in mega AVR we are having various microcontroller, like at mega 8, at mega 8L, at mega 16. So here we are going to use at mega 8, at mega 8. Okay, so in that one we are having 8 KB of ROM. 8 KB, I know it's a very small amount according whatever you have, maybe you have imagined, but it is sufficient. It is sufficient for our project. You can make various types of project in this amount of memory only, 8 KB. And the RAM is 1 KB. EEPROM is 512 byte. And we are having in at mega 8, at mega 8 we are having total number of pins is 28, 14 one side and 14 other side. Okay, so in that one, for controlling input output devices we are having 23 pins. You can program it as these 23 pins can be programmed as input or output as per your requirement. And we are having 3 timers, 19 interrupts, and the operating voltage range is 4.5 voltage to 5.5. But standard we used to give it 5 voltage. We can't give it more than 5.5. If you will provide more than 5.5, it may get burned. And the operating frequency is 0 to 16 megahertz, but here we will use 12 megahertz. You can change it as per your requirement or as per your need for the speed, but here we will use 12 megahertz. So this is the specification of our microcontroller, what we are going to use in the next videos. So here is the description about the 8-bit. What is 8-bit? 8-bit, that means already I have told you that 8-bit, that means it can process 8 bit of data. Bit, that means smallest unit, smallest unit. It can be 1 or 0. So 8 1 and zeros it can process at a time. And here we are going to use at mega 8. So what, uh, everything is every name is having their meaning. So here at at 80, 80 stand for atmel. Mega is the series. We have discussed about the categories. So we had teeny, mega, x mega. So here we are using mega family. So mega is the series, and 8. So what is 8? 8 is 8. Is it denoting 8 bit or ROM? So it is denoting ROM. 8. 8 KB of ROM. Suppose if we will use at mega 16, so that means it is having 16 KB of ROM. So the last number is denoting its ROM size. We have already discussed about the memory. so we are not going to discuss here. And then coming to the packaging, we are having every IC generally every IC comes with two types of packaging. One is PDIP and the other is TQFP. PDIP, that means plastic dual inline package. In that one, you are having uh, two sides of pin only, two types, not all the sides. And uh, in the TQFP, we are having all sides pin. That means quad. Its full form is thin quad flat packaging. Okay, so that means it is having four-sided pin. So generally, for the study purpose, we use PDIP so that we can easily connect pins and we can understand the pins, because TQFP is generally using a thin film technology, technology. So so for that one, for the study purpose, we prefer PDIP. Then coming to the pin diagram. Pin diagram. So it's very important. Actually, every manufacturer used to provide a pin description, because if you see a microcontroller, there is nothing written on it. Okay, because every pin is having their own specific function or feature, you can say. But how you can know that which pin is having what function? Okay, so for that one, every manufacturer used to provide a pin description, pin diagram. So by understanding that one, you can easily make the connection. So here, here maybe you are seeing a small semicircle. If you see a real microcontroller, then you will get this symbol. Okay, a small semicircle. This is denoting the upper side of your microcontroller. Upper side of your microcontroller, and we used to count the number of pins from the left side of this semicircle. So it starts from up to down, 1, 2, 3, 4 till 14, and from the next side we used to count from down to up, like 15, 16, 17, 18, 20, and till 28. So every pin is having their own feature, own function. So we have already talked that we have already talked about this one, that it is having total 28 pins, in which 23 pins are input output pins. That means by 23 pins you can control 20 input output devices, and the 5 pins are for the power supply. Here we need to connect VCC, ground, and here these power supply is for the ADC. We will discuss about these pin in detail while discussing about the ADC, that means analog to digital converter. Okay, so first of all we will discuss about the uh, general purpose input output, that means input output pins. So here these are the names of the pins, like PC, PD0, PD1. So actually we are having total 23 pins. So these pins are divided into three parts, and these are known as port. Like and it start from, sorry, it start from port B. This pink color, is denoting the port B block, port B. So it's start from PB0, PB1, PB2, PB3, PB4, PB5, PB6, PB7, and then we are having port C, PC0 here. This is green color is indicating port C. So exceptionally in port C we are having 7 pins, and but in port B and port D we are having 8 pins. So here we have started with the PB0 and ends with the PB7. That means total we are having 8 pins. But in C port we are having PC0 to PC6, that means total we are having 7 pins, and in port D we are having PD0 to PD7, that means it is also having 8 pins. So 8, 8, 16 and 7, total we are having 23 pins. So these are the names of input output pin like PD3, PD2, PD6, PB0, like this. So uh, and here maybe you are saying that in something is written in brackets, so it is the multiplexed function or feature of this particular pin. So suppose we can take an example of reset. So PC6 is a simple input output pin, but its multiplexed function is reset. That when if you want to make reset of this microcontroller, if you want to make reset, then you need to use this pin. Suppose and here we are having RHD, TXD. So every pin is having their own multiplex function. We will discuss later in detail every multiplex function while learning advanced stages. So hope you have understood about the pin description. If you are having any query, then you can ask me, or you can mail me, or you can comment below. So